Hello, good day. How are you today? You're good, right? Okay. Are you ready for today's lesson? You are? That is good. So today in mathematics, we are going to be looking at differentiation of algebraic 2. Okay? So under today's lesson, we're going to be looking at rules of differentiation, sum and difference, chain rule, product rule, quotient rule, okay? So are we ready? So let's first of all look at the rules of differentiation. We have the constant rule states that the derivative of a constant is 0. Okay? Any constant, 3, 7, 2, 5 is always 0, okay? The derivative of any constant is always 0. Then the power rule. The derivative of a variable raised to a constant power is the constant times the variable raised to the power decreased by 1. So if you have x raised to power n, the derivative is n, so it will be x raised to power n minus 1, okay? We're going to be looking at examples to help us understand this. We have the sum and difference rules. The derivative of a sum or difference of a function is the sum or difference of their derivatives. If you add or subtract functions, just find the derivative of each part separately, okay? Product rule. The derivative of the product of two functions is the derivative of the first times the second, plus the first times the derivative of the second. If you multiply two functions, find the derivative of the first, multiply it by the second, and then add the product of the first and the derivative of the second. That is what this means, okay? The quotient rule. The derivative of the quotient of two functions is given by the numerator's derivative times the denominator minus the numerator times the denominator's derivative, all divided by the square of the denominator. We are going to be looking at an example to help you understand this better, okay? If you divide one function by another, it's a bit more complex. So you find the derivative of the top, multiply by the bottom, subtract the product of the top and the derivative of the bottom, then divide by the square of the bottom. We're going to understand this better, okay? Then the chain rule. The derivative of the composite function is the derivative of the outer function evaluated at the inner function multiplied by the derivative of the inner function. So if you have a function inside another function, find the derivative of the outer one with respect to the inner one, then multiply the derivative of the inner function, okay? So let's go through some examples for each of the rule, okay? We start with sum and difference. Let's say represented with this, y equals to 2x, okay? This is just the beginning, okay? If we were to differentiate this, remember differentiation is the change of variable over another. So we are differentiating y from x. So how do we write that? Differentiation of y over differentiation of x. So the y over the x. So we have 2x. There's an invisible 1 raised to power of x, okay? Remember the power rule, right? If you have a raised to power, normally you have a raised to power is minus 1, okay? Whatever number you have as the raised to power is minus 1. So we have 1 over this x, an invisible 1 over this x. So it's minus 1, okay? But first, 1 times 2, remember you're using the power to multiply 2 first. 1 times 2 is going to give you 2. X raised to power 1 minus 1. Remember we are minusing 1. So 1 minus 1 is 0. So x is raised to power 0 now. So 2x raised to power 0, x is 0. So anything raised to power 0 is 1, right? You remember. So 2 times 1 is going to give you 2. So the y over the x is equals to 2. Do you understand? Let's look at another example. Here we have some operations. Y is equals to 3x squared plus 4x minus 1. We are to differentiate this. So dy over the x will be equals to 2 times 3 is going to give you 6x. Remember, we are minusing, okay? Let me write it out. So we have 6x raised to power 2 minus 1. Remember the power rule, right? Good. So 6x raised to power 2 minus 1 plus 4. How did we get this 4? Remember, there is a 1 here. 1 minus 1 is 0, and n2 raised to power 0 is 1. So 4 times 1 is 4 minus 1. Remember, if you are differentiating a constant, is 0. Okay? So 1 here is a constant, right? So it's 0. That is the rule. Okay? So we have y equals to 6x minus raised to power 2 minus 1 plus 4 minus 0. 2 minus 1 is 1. So we're left with 6x plus 4 minus 0. Okay? So dy over the x is equals to 6x plus 4 minus 0. Do you understand? Okay, good. So let's look at an example on chain rule, okay? So the chain rule has a formula, okay? The formula is the y over the x, which is differentiation of y in respect to x. So the formula is equals to dy over du times du over the x, okay? This is the formula for chain rule. So let's look at an example using this formula. So y is equals to 3x minus 2 raised to power 2, okay? Bracket 3x minus 2, bracket close, raised to power 2. So now we are going to say, let u be what is inside this bracket, okay? Everything inside the bracket except the square. So let u be 3x minus 2. This is what is inside the bracket. So everything inside the bracket, let u be everything inside this bracket, okay? So now we have gotten u. U is equals to 3x minus 2. So now we are going to be looking at differentiation of u over differentiation of x, okay? Differentiation of u in respect to x, which is du over the x. So we have to differentiate u to get the answer of du over the x, okay? So we're going to be using our general method to differentiate this. We have 3x here. Remember, it's raised to power 1. Since there is no number raised to power here, it's raised to power 1. So 1 minus 1, remember, in the power, any number that is there, we are subtracting 1 from it. So here the power is 1. If here the power was 2, we subtract 1. If it was 3, we still subtract. But here the power is 1, so we still subtract 1. So 1 minus 1 is 0. X raised to power 0 is 1, right? So we have 3 here. Do you understand? We have 1 up here. Like the raised to power is 1, okay? So 1 times 3 is going to give you 3. Here we are left with x raised to power 1 minus 1, which is 0. And anything raised to power 0 is 1. So we have 1 here. So 3 times 1 is going to give you 3. So du over the x is 3. Do you know why I didn't touch this 2? Remember, if we're differentiating a constant, it's 0. So there's no need, okay? It's 0. So du over the x is equals to 3. But y is equals to u raised to power 2. Do you understand that? This is our y, right? Bracket 3x minus 2 raised to power 2. But now we said let u be this term inside the bracket, right? So u is this term. Okay? That's why we have 2 raised to power u raised to power 2, sorry. So y is equals to u raised to power 2. U is this, and this is what is inside u. So we're using u to replace this, okay? Do you understand? So u is raised to power 2. So how do we differentiate y from u? So the differentiation of y over du, which is differentiation of y in respect to u, is equals to, how do we differentiate this? 2 times 1, there's an invisible 1 over here. 2 times 1 is 2. Okay, so we have 2 here, and this 2, remember we are minusing, minus 1 is 1. So we have 2u, okay? We have 2u here. So dy over du is equals to 2u. Do you understand? So we have gotten du over the x, which is 3, and the y over du, which is 2u. Okay? So we are going to simplify these our values into this formula. So dy over du is what? 2u, right? So we put 2u. Remember, this is the formula we're simplifying into. Dy over the x, okay, is equals to, the first one here is the y over the u, and the y over the u here is 2u. So we have 2u times du over the x. Du over the x here is 3 times 3. So 2u times 3 is going to give you 6u. So dy over the x is equals to 6u. But u is this. So we simplify u into this, okay? So dy over the x is equals to 6 bracket 3x minus 2 bracket close. Do you understand? So this is our final answer, okay, from this. So dy over the x is equals to 6 bracket 3x minus 2 bracket close, okay? So differentiation of y in respect to x is this, from this, okay? Do you understand that? Good. So we can apply the chain rule to this, right? If we see an equation like this, if we see a function like this, we can solve it using this chain rule formula. Okay, good. So next we're going to be looking at example on the product rule. The product rule also have a formula, okay? dy over the x, differentiation of y in respect to x is equals to, the formula is u dv over the x plus v du over the x. So we're going to be looking for dv over the x and du over the x, okay? So let's use those functions to apply with this rule. So here we have y is equals to 3x minus 2 bracket open bracket close, then bracket open again, 4x raised to the power 2 minus 1 bracket close. So first we will say let u be this inside the first bracket, okay? The function inside the first bracket, which is 3x minus 2. And let v be the second function, okay? This inside the second bracket, the second function, 4x raised to the power 2 minus 1. So u is equals to 3x minus 2, and v is equals to 4x squared minus 1, okay? So first we're going to be looking for du over the x. We're going to be differentiating u from x, which is du over the x. Differentiation of u in respect to x. We're going to be differentiating this using the general method, okay? So 3x raised to the power 1 here. 1 times 3 is 3. Then remember x is raised to the power 1, which is 1 minus 1. You're minusing 1, right, from the power. So it's 0. X raised to the power 0 is 1. So 3 times 1 is going to give you 3. A constant when differentiating is equals to 0, right? So du over the x is equals to 3. We got 3 from differentiating this, okay? So du over the x is 3. Now let's differentiate v from x. So the v over the x, which is differentiation of v in respect to x, how do we differentiate this? 2 times 4 is going to give us 8. 8x raised to the power 2 minus 1. 2 minus 1 is 1, right? So we have 8x raised to the power 1, which is still 8x. Differentiating a constant is 0, so 1 is equals to 0. So dv over the x is equals to 8x. You know how we got it, right? 2 times 4 is 8. This 2 minus 1 is 1. So x is raised to the power 1. So 2 times 4, which we got 8, is 8x. Okay, don't be confused. So we have gotten du over the x, which is equals to 3, and dv over the x, which is equals to 8x. So looking at our formula, we have gotten everything we need, right? We have u, we have